Alright everybody, welcome back for part 2 of the 4.5 solving polynomial equations. We're going to specifically look at the rational root theorem and irrational conjugates theorem in this section and see how we'll apply those. So first we'll talk about our riddle of the day. So what is tall when it is young and short when it is old? What is tall when it's young and short when it's old? The answer to that is a candle. Candle is tall when it's young and then gets shorter as it gets older. Okay, so jumping right in on the rational roots theorem, this is on page 98. Page 98 of your notes. So the rational root theorem is specifically this here, but mainly this fraction down here. We want to look at that fraction here to see really what this is. It says P over Q, and P is the factor of the constant term. So you're going to have, your polynomial equation. You have your polynomial, like here's an example of what it could be, something like this, some starting term, ending term. So you have your constant term. Your constant term is always in the back, this last one. It's always the one without the variable. So it's the factor of the constant term. So all the factors of the constant term could be that. So it's a factor of the constant term over the Q, which is a factor of the leading coefficient. And that would be the number in front of your highest term right here, right at the front, right at the beginning. So that's going to be quite a few of them, because it could be all the factors of all the constants, and all the factors of the leading term. So if that leading term is 1, if it's just a 1 there, it's actually easier. But if it's like a 2, then it could be 2 possible factors down here, a 1 and a 2. For the constant term at the top, this is always going to be plus or minus, because you could have the positive form or negative form of that. So I put plus or minus for this right here, because we'll see that. All right, so let's go on to page 100. On number 11, it says, according to the rational roots theorem, which is not a possible solution of the equation. All right, so now let's start trying to figure out, using that rational roots theorem, which is the P over Q, P being all the factors that are of this constant right here. So here's our P. P is this one, so 7. So we're looking for all the factors of 7. Well, there's only 2 of them. It's just 1 and 7. So I'll put a 1, maybe a comma, 7. And I'm going to put plus or minus 1 and plus or minus 7. Like I said, it's going to be plus or minus of those ones, because you could have a positive 7, negative 7, or positive 1, negative 1. And it's over the Q. Q is this number here. So Q is this one here. It's 2. So what are the possible factors of 2? Well, only just 1 and 2. So plus or minus 1 could be over 1. Plus or minus 7 could be over 7. I got to do it again, because now I have to show that plus or minus 1 could be over 2, and plus or minus 1 or plus or minus 7 could also be over 2. See how when this is a number up here, it gets a little more complicated, because you have to do actually 2 groups of them. And so now here's all the possible solutions, they said, which is not a possible solution of the equation. All the possible solutions are right bound up into these numbers. So that would leave us with a positive 1 over 1. So we could have 1 or negative 1 here, 7 or negative 7 here. We could have a positive or negative 1/2 here, or a positive or negative 7 over 2 here. Okay, so out of this group of numbers here, what are they? So here we have some decimals. So 3.5 is the same thing as 7 over 2. So we get that. Okay, so 7 over 2 is one of the solutions that we could have. 7 over 2 is the same thing as 3.5, so positive. So that one's good. That one could be a solution. 0.5 is a 1/2. That's one of these guys right here, positive 1/2. Same thing as 0.5, so it works. 7 is a solution over here. We could have positive 7 from this one. So that works. 2 is the one that is the answer to this. It's the only one here that is not a possible solution, because it's not a part of these numbers. Okay, like I said, all these numbers we could have, 1 and negative 1, 7 or negative 7. That does not include a 2. Here's a positive or negative 1/2, positive or negative 7 over 2. So 2 is the only one that's not one of these possible solutions down here. Okay, that's all that is. So here's all your possible solutions that you could get. Okay, so number 12, right below number 11 there, find all the real zeros of the function. Now I'm going to change this problem here, so go ahead and just line this one out, cross this problem out, and we're going to write a new problem instead here. So here's the problem we're going to do instead. This is going to be a bit easier than the one that they gave us here. I didn't want to go with such a hard one right off the bat here. So let's try this one instead, which is just x to the third minus 5x squared minus 2x plus 24 equals 0. Find all the real zeros of the function. Now, we've done this before with factoring by grouping, but the problem here is that grouping will not work. If we try to factor out the GCF here, that's going to be x squared, that'll leave us with an x minus 5. Factor out negative 2 from this, that's going to be an x minus 12. That doesn't match. X minus 5, x minus 12 doesn't match. So grouping doesn't work here. So factor by grouping is not working. So if factoring by grouping won't work, what do we do now? Well, now we're going to use that rational roots theorem, and using synthetic division we're going to figure out the answer to this, finding all real zeros. So using that rational roots theorem, that's going to be able to help us find all our options for the multipliers. So all the options that we have for our multipliers are going to come from the rational roots theorem, which remember is P over Q, which again P stands for the constant, Q is for the leading coefficient. So right there, so constant over leading coefficient. So that's what we want. So we're looking at the constant number, which is 24 in this case, and the leading coefficient, which is 1. So that's why it's a little bit easier, because the leading coefficient is 1. So if I think of all the factors of 24, starting with 1, so we could start with just writing down 1 and 24. So we could do that. Let's just start with 1 though, so plus or minus 1. The next one would be, so 1 and 24, 2 times 12, so let's go put 2 down here right now. So 2 and 12, we know that. And then 3 times 8, so 3 is another factor. 4 also goes in it 6 times, 4 is another factor. 5 does not go in, but 6 does. So there we could see where we got back to this one now, 4 times 6. And so now we can go 3 times 8, that's the next one over here. And this one was 2 times 12, so 12 is the other one over here. And then 1 times 24. So 24 is now our last one. And it's all over the leading coefficient. There's only one number here, which is 1, for the possibilities of the factor of 1. So 1 has only one possibility. That's why it's pretty easy with this one. We can just put all of these over 1, and we see all the options for our multipliers to be. Now you might be thinking, that's a lot of numbers, and it is. We got like 16 possible numbers here with all of these. So we just don't want to start going down the list. I would start with some easy ones with these. Just start with 1, the negative 1, 2, the negative 2. Those are going to be your multipliers for our synthetic division. So we can come over here and start with 1. So if I just start with 1 as my multiplier, and then I have my 1, my negative 5, negative 2, and 24. So 1, negative 5, negative 2, 24. And what am I looking for here as I do this? I'm looking for my remainder, which is always going to be this last number here, to be 0. Once I get that to be a 0, then I know that that was a factor. So right now with 1, when I'm talking about 1, I'm talking about the factor of x minus 1, right? The opposite of this would be negative 1. So we're looking to see, is x minus 1 a factor of this now, using the multiplier of 1. And it will tell me that if this is a 0. So we start bringing down the 1 first. 1 times 1 is 1. This makes negative 4. Negative 4 again here. And so now I have negative 6. Negative 6 again right here. So you can see I'm definitely not going to get a 0 here. So this is not working. So that one didn't work there. So let's try negative 1, see if maybe that one is. And when I'm looking for negative 1, I'm looking to see, is x plus 1 a factor, right? The opposite sign there, plus. So is x plus 1 a factor with these same numbers, 1, negative 5, negative 2, and 24. Bring down my 1. And I'm looking for this last number to see if this is a 0. 1 times negative 1. This is going to be negative 6. Negative 6 times negative 1 is positive 6. This makes positive 4. That makes negative 4 here. So again, I'm not going to get 0. So that's not a factor either. So let's keep trying the next ones. Now let's go to 2. Let's go to positive 2. And put the same numbers down. 1, negative 5, negative 2. And you just got to keep doing this until you find one that is a factor. And once we do that, then we can kind of get towards our answer. So we bring down our 1. 1 times 2 is 2. That makes negative 3 here. Negative 3 times 2 is negative 6. That makes negative 8 there. Negative 8 times 2 is negative 16. So right here, am I going to get a 1? No, I'm not going to get, or not going to get 0. Sorry, am I going to get a 0? No, I'm not going to get 0. So again, this one didn't work either. So let's try negative 2. We'll just keep doing this. I'll go to 3 next, and I would go to 4. Eventually, one of these is going to be a factor and give me a 0. So we got the same numbers, 1, negative 5, negative 2, and 24. Draw my line, bring down my 1. 1 times negative 2 is negative 2. That makes negative 7. That makes positive 14. And take 2 away, now I have positive 12. It makes negative 24. And there we go, look at that. We're going to get 0. 24 minus 24 is 0. So this one here, which is really x plus 2, okay, that is the actual factor now of this polynomial. So there's one of the zeros. One of the zeros is negative 2. So negative 2 is one of the answers, is one of the zeros. It's the factor from x plus 2. What's left here, remember we could see what's left here. Here's my constant, my x term, my x squared term. Let's go ahead and put that in. So we're going to see this is my x term here, this is my x squared term there. So it really is x squared minus 7x plus 12. And now using, and we could say equals 0 for this. Using factoring, we could try to see, can we solve this with factoring and get 2 more factors out of this? Let's try with the simple method and just see, can this be factored? So we can say x's go up front. 2 numbers that multiply to give us 12, that add to give us 7. There is 2 numbers with 3 and 4. They're both the same, they're both negative. So there's 2 other factors. We can go ahead and use the zero product property to find those 2 zeros. So we know x is going to equal positive 3 here when I add 3, and x is going to equal positive 4 from this one. So there's my 2 other zeros. So if I went over to these two, positive 3, positive 4, also would have given me a 0 on these. So my roots here, so the final answer for the roots, what does x equal here? It's going to be x is going to equal negative 2, we found that one, and positive 3 and positive 4. So there's the final answer for all of the roots. If I needed to factor this, let's just say I needed to factor that, and I could use the rational roots theorem, the same thing, and factor it. Here's my factors right there with x plus 2. So the 3 factors of this would be x plus 2, and then this would be x minus 3, x minus 4. So those are the other factors that we could have seen as well. So if we needed to factor it, those are the 3 factors of this polynomial. Okay, if you go back to page 98, we're going to look at the irrational conjugates theorem. The main thing here on this one is we're going to actually be kind of going backwards. They're going to give us the answers. They're going to give us what the roots are, and we're going to write the polynomial from that. So basically what we're seeing here is, it says, if f is a polynomial function with rational coefficients, a and b are rational numbers, square root of b is irrational. So it says if a plus square root of b. So if you have this, if that is one of the zeros, if that is one of the answers there, then this also has to be an answer here, a minus the square root of b. So if you know that this is an answer, then this one also has to be an answer. Okay, so here on number 13, I'm actually going to have us kind of draw a line down the middle between, right below this one, and then write these numbers also on the right. So we're going to do like a 13a and a 13b from this. So 13a is going to be this one here where it says it, and then 13b will be with these 3 numbers here. So for 13a it says, okay, we'll write the polynomial function g, so we'll see like g of x, of least degree that has rational coefficients, a leading coefficient of 1, and the zeros of of this right here, negative 5 and then a 4 plus a square root of 2. So it's just like with the irrational conjugates theorem. Remember, the conjugate is the opposite sign of this, 4 minus square root of 2. If this is a 0, which is what it's saying here, if this is a 0, then its conjugate also is a 0, so we can say that that is a 0 as well. 4 minus the square root of 2 is also another 0 of this. We need to realize that. So now if these are zeros, we can write these down as factors. Obviously, negative 5 is going to be easier. We could start off with just saying the opposite of this, right? It's going to be x plus 5, and we see that. So g of x, here's our function notation like it said for us to do, equals x plus 5 from the negative 5. When we plug it into the parenthesis, it changes signs. This one here is going to now be x, plus this right here, or x minus this. So it's going to see that it's going to be an x minus this one right here. It's a positive 4, so x minus 4 square root of 2. And then the same thing for this one. We'll plug this one in. And this will be, oh, come on, there we go, x minus 4 minus square root of 2. So these ones are x minuses on these ones because 4 is a positive number up front. 5 was negative, so it's a positive in here with the 5. Okay, so now what we're looking at is we need to multiply these. Let's multiply these two first. It's going to be easier to multiply these two times each other first, and then we'll multiply it times the x plus 5. So we're just going to do a bunch of multiplying to get our polynomial. So starting off with, we see it. We're going to multiply the x minus 4 times each other. So that's our first part. Our first part is to multiply the x minus 4 times the x minus 4. So that's going to be a little easier to do. It's like using FOIL with that. So multiplying the x minus 4 times x minus 4, that's going to give us this up here. And then we're also going to multiply the square root of 2 times the square root of 2. Because really what we have is a sum and a difference. X minus 4 is the same thing up front. The 2's are the same thing in the back. We have a plus and a minus. So it's a sum and a difference. So you're just doing the first ones, which are the x minus 4's, times the last ones, which are the square root of 2's. So you can always do that when you just have a sum and a difference, and that's what we have here with what's inside these parentheses. You have the same things here. X minus 4 is the same up front, and so you can multiply those for the first ones. Square root of 2 is the same in the back. We can multiply those two for the last ones because it's a plus and a minus. So we're square root of 2 times square root of 2. We know that's going to give us the square root of 4. So now as we multiply this, we're going to see g of x. G of x is going to equal the x plus 5, just like we have up here. But now we got to start putting this down here. So we're going to first multiply these two times each other. X minus 4 times x minus 4. That's going to be an x squared from that. The outside is going to give me negative 4. Inside is also going to give me another negative 4. That makes negative 8x there for the middle. And negative 4 times negative 4 is a positive 16. And then when we're going to multiply these two times each other, we're going to get the square root of 4, which is going to be 2. So positive times negative would be a negative here. So positive times the negative is negative, and then that's going to be our 2. And so now that's what we have. Let's clean that up real quick here, just by putting that together. So x plus 5, and now it's going to be x squared minus 8x, and 16 minus 2 is going to be 14. So now I have these two times each other. So just a binomial times a trinomial. It's just going to use a distributive property, starting with x times those 3, then 5 times those 3. So this is what we're going to be getting now. With x times x squared, we're going to get an x to the third power. X times negative 8x is 8x to the second power, and x times 14 is going to give us 14x. And then the 5 times x squared is a 5x squared. We'll just put that right underneath the other x squared there. 5 times the negative 8x is going to be a negative 40x. And then 5 times 14, so that's going to be a positive 70. And so now we're just going to combine like terms going down. So we're going to say our g of x here. G of x is now going to equal x to the third power. And this is going to now be a negative 3x squared. When I subtract here, I'm going to get a negative, take 10 away, it's 30, 4 more, it's 26, so it's 26x. and then a plus 70 just comes down. So there is our answer here for this one. So that gives us our polynomial. It says write a polynomial g, which we did right here. Here's our polynomial g, and with these are the roots. These are the zeros here. So let's do the same thing on this one being actually a little bit easier than the last one because they don't have the rational ones here with the square roots of 2 in them. We just got -4, -2, and 5. So it's like 3 of these numbers put together. So we can see how we'll do that. We'll start off with g of x is equal to, this is going to be x plus 4 from this one. Remember, opposite sign. This one's going to be x plus 2, opposite sign. And this one's going to be x minus 5, again, opposite sign. And now we just got to multiply 2 together at the same time. So let's start multiplying these last 2 together. I just want to maybe do that first. It doesn't matter which ones you multiply together first. So we're going to start with the x plus 4. We're going to keep that here for a minute as we're multiplying these 2 together. So x times x is x squared. X times 5 is -5x, and this will be a 2x from the inside. So take 2 away from -5. That will give me a -3x from the middle term. And then 2 times -5 is going to give me -10. Remember, I'm getting the middle term by doing the outside plus the inside. So I'm combining the outside term, which was -5x, combined with a positive 2x there, giving me this one, -3x. Okay, so now we have a binomial times a trinomial, just like we did here. So we'll do the same thing. So x times x squared gives me an x to the third. X times that middle one is -3x squared. X times -10, -10x. Then 4 times x squared is 4x squared here. 4 times -3x is -12x. Come on, x there. That looks weird. -12x. There we go. And then my last one, 4 times that one would be -40 at the very end. So we'll combine this all together. So our g of x now will equal sorry about that with the bell. G of x now will equal x to the third. This will be a positive 1x squared. This is going to be -22x, and this will be -40. So there is our final answer then on this one. There's our polynomial function with these 3 being the zeros. Okay, so our last one here, number 14, just says use the information in the graph to answer the questions, what are the real zeros of the function? So that should be pretty easy to see what the real zeros of the function are. That's always your x-intercepts, and you can see where they're crossing the x-axis right here are going to be the real zeros. So you can mark those off there. This one's going to be -6 here. This one's at 0. So -6 and 0 is the answer to A. That's just what the real zeros are for that one. Then it says on B, write an equation of the cubic function in factored form. So we know that this is supposed to be a cubic function. So our highest exponent should be x to the third power. So it's going to have 3 x's. Well, we only have 2 x-intercepts, which means one of these must be a repeated solution. And the repeated solution, again, is the one where it just touches and then goes back up. Remember, this one, when it's going through, is not the repeated solution. That would just be one solution. This one's going to have an even number of solutions right here. So that one's going to have 2. So that 0 there, that's the repeated solution. There are 2 of those. And so as we start to realize, okay, what we're going to do here is we're going to plug this in to our, just our binomials. So we're going to say x minus 0. There's 2 of them though, so I'm going to put squared on that one. And it's going to be x plus 6 on the other one, just one of those. Remember, it's the opposite sign. So I have -6 here, so it's x plus 6. X minus 0, it really doesn't matter whether this is plus or minus because it's just a 0. So I just always usually put minus. But once we clean this up, x minus 0 is just x, so it's really going to be an x squared times this binomial here. And that's all we need to say for our answer. We could distribute that in there if we wanted to, get x to the third plus 6x squared. That could be the same thing, or we can leave it this way. So it doesn't matter which way you actually have that answer. Alright, so that concludes our lesson for 4.5. Now you want to continue on with your homework from the assignment. and get that completed and put into the computer for big ideas. All right, I'll see you in class.